The last day we had seen the points regarding percentage composition, empirical formula, molecular formula, all these things we had seen. And finally, we have to see some concentration terms. Suppose you are given a solution. How can you express the concentration of a solution? Do you hear me? Okay. So how can you express the concentration of a solution? Suppose you are adding glucose into water. Glucose is added into water and it is shaken well. You can see that glucose disappears in water. We say that glucose is dissolved in water. And the resulting mixture of glucose and water, that is known as a solution of glucose. Okay. You take sucrose or cane sugar. Cane sugar is mixed with water and it is shaken well. Then also you can see that sucrose or cane sugar crystals disappear in water. Here also we say that cane sugar or sucrose crystals dissolve in water and the resultant mixture is known as a solution. A better example is the dissolution of a sodium chloride, a common salt, in water. So all these things dissolve in water to give solutions. Here we can define a solution. What's meant by a solution? Solution is a homogeneous mixture, a uniform mixture of two or more substances. A homogeneous mixture, a uniform mixture of two or more substances. Each substance is called a component. So we can define solution as a homogeneous mixture of two or more components, two or more substances, or two or more components. Suppose there are only two components, as we have seen, sodium chloride plus water, glucose plus water, cane sugar or sucrose plus water. There are only two components. Anyhow, in a solution, one component, one substance is known as solvent. The other component, that is known as solute. So in a solution, there will be a solvent component and a minimum a solute component. If there are only two substances or two components in the solution, then it is called a two-component system or a binary solution. So, in a binary solution, there are only two substances, a solution of two substances. That is a two-component system. In the binary solution, in the two-component solution, one component is known as solvent and the other component is known as the solute. So, let us go back to the definition of a solution. We will take all these things in detail the next solution. To take a solution. So, solution is a homogeneous mixture. Homogeneous mixture of two or more components. Two or more components. Solution, I shall write it again. Solution is a homogeneous mixture. A homogeneous mixture of two or more components. Mixture of two or more components. Two or more components. Two or more substances. That is called a solution. If there are only two components, then it is called two components. Then it is called a binary solution. Binary solution. Binary solution. In a binary solution, there are only two components or two substances. In a binary solution, one component is known as solvent, and the other component is known as solute. Solvent and solute, two components, solvent and solute. Now, let us think of the various terms by which the concentration of a solution is expressed. That is the heading given to you. That is the concentration terms. So, concentration terms. The various terms in which concentrations of solutions are expressed. One is called the mass percentage. One is the mass percentage. First one, mass percentage of a solution. Say, you think of a binary solution, two component system. In a two component system, there are only two substances. One is solute and the other is solvent. Let us take the mass percentage of the solute. What's meant by the mass percentage of the solute? It is the amount of the solute present in 100 parts of the solution. Amount of the solute. Amount of solute in amount of solute in 100 parts. 100 parts of solution. That is called the mass percentage of the solute. Similarly, the mass percentage of the solvent. That is the amount of the solvent in 100 parts of the solution. So, we can write an equation like this. Mass percentage of a solute, is equal to mass of solute by mass of a solution, not a solvent, solution. Mass of a solution into 100. And this will give you the mass percentage of the solute. Mass percentage of the solute. The percentage of solute in the solution is equal to mass of the solute by mass of the solution into 100. How do you get the mass of the solution? Mass of the solution is obtained by adding the masses of the solute and solvent. Masses of the solute and solvent are added so that you will get mass of the solution. Let us take an example. The example is not given in your notes. So you write this example. You write a problem. You write down the problem. You write down a problem. Say, so 10 gram, suppose 10 gram of glucose. You write down the problem. 10 gram of glucose, 10 gram of glucose dissolves in 90 gram of water. 90 gram of water. 90 gram of water. A solution is given to you. Here glucose is the solute and water is the solvent. Glucose is the solute and water is the solvent. Now you calculate the mass percentage of glucose. How can you find out? So the percentage of, mass percentage of glucose, calculate. Glucose is equal to mass of glucose by mass of solution into 100. Mass of solute by mass of solution into 100. Here the solute is glucose. So mass of glucose, that is equal to 10 by mass of solution. Mass of solution is the sum of SUM, the sum of the masses of the solute and solvent. That is 10 plus 90. And that is the mass of the solution. And into 100. Into 100. Mass of the solute by mass of the solution into 100. That is equal to mass percentage of the solute. In the given problem, the solute is glucose. So the mass percentage of glucose in the solution is equal to mass of glucose 10 by mass of solution. You add both. 10 plus 90 into 100. That is the mass percentage of glucose. And this is equal to 10 by 100 into 100, and that is equal to 10%. And that is the mass percentage of the solute, glucose. Then the mass percentage of the solvent, if it is asked, that is equal to mass of the solvent, 90 by mass of the solution, 10 plus 90 into 100. And that will be equal to 90%. 90%. So we can express the concentration of a solution in terms of the mass percentage. Mass percentage. Mass of the solute by mass of the solution into 100. Another unit, that is mole fraction. That is the second unit. Mole fraction. Mole fraction. Mole fraction is expressed by the symbol X. Mole fraction, the symbol for mole fraction is X. And what's meant by mole fraction of a solution or a component? Mole fraction of the component is the ratio between the number of moles of that component and the total number of moles of the components. That is called the mole fraction. The number of moles of the component by total number of moles. So mole fraction X, that is equal to number of moles of the component, whatever it is, the component, number of moles of the component by total number of moles, total number of moles of all components, and that is called the mole fraction. Which one? Okay. Okay, so mole fraction X, that is equal to number of moles of the component by total number of moles of all the components, and that ratio is called the mole fraction. We have seen that in a binary solution, there are only two components. The one is solute and the other is the solvent. Suppose number of moles of solvent solvent. You call solvent as A. Let it be Na. Number of moles of the solvent A is equal to Na. Then number of moles of solute. Number of moles of solute B. Let it be B is equal to Nb, and that is the number of moles of the solute. That's equal to Nb. Now, what will be the mole fraction of the solute? Mole fraction of the solute. To get the mole fraction of the solute, you divide the number of moles of the solute by total number of moles of both the components. So, mole fraction of solute, mole fraction of solute is equal to, you call it as XB, solute B. That is equal to number of moles of the solute, that is equal to NB by total number of moles of solute and solvent, that is Na plus Nb, and that is the mole fraction of the solute. From here, you can find out the mole fraction of the solvent also. So, mole fraction of solvent, you call it as XA, solvent XA is equal to number of moles of the solvent, that is equal to Na by total number of moles, Na plus Nb, and that is equal to mole fraction of the solvent, if there are only two components, solvent and one solute only. You can see that the sum of the mole fractions, SUM, the sum of the mole fractions is equal to, that is equal to 1. So, XA plus XB, that is equal to 1. So, if you get the mole fraction of any one of the components, you can find out the mole fraction of the other component by simply subtracting the mole fraction of the given component from 1. Say, for example, here, XA is equal to 1 minus XB, or XB is equal to 1 minus XA. That is so because XA plus XB is equal to 1. All right. Let us try to solve a problem. You are not given the problem in the notes. You please take down the problem. Write down the problem. Write down the problem. Say 1 mole of glucose. 1 mole of glucose, you write. You take down. 1 mole of glucose is dissolved in 2 moles of water. 2 moles of water. 1 mole of glucose is dissolved in 2 moles of water. Then, what is the mole fraction of glucose and water? Mole fraction of glucose and water. Okay. Here, glucose is the solvent, so solute. So, the mole fraction may be written as XB, and water is the solvent. So, you write it as XA, mole fraction of water is equal to XA. And how to calculate this? You know, mole fraction XB is equal to number of moles of B, NB, by total number of moles, Na plus Nb. Therefore, mole fraction of glucose XB is equal to number of moles of B, Nb by Na plus Nb, that is equal to number of moles of glucose, that is equal to 1 by total number of moles, Na plus Nb. Na, that is number of moles, this is Na, number of moles of the solvent. And this is equal to NB, number of moles of the solute. So right, 1 by Na plus NB. Na is equal to 2 plus 1. 2 plus 1. That is equal to 1 by 3. You can simplify that if you want. Now you find out the number of mole fraction of water. How to get the mole fraction of water? You can follow the same method. Or, XA plus XB is equal to 1. Therefore, mole fraction of water XA is equal to 1 minus XB, and that is equal to 1 minus 1 by 3. 1 minus 1 by 3. That is equal to, you simplify that yourself. You simplify that. That is one method. Or you can find out the XA by taking the ratio between Na and Na plus NB. That is, XA is equal to 2
by 3.
Another 2 divided by 2 plus 1. Same method. That is equal to 2 by 3. 2 by 3. And this will be 2 by 3. This is 2 by 3. Here 1 by 3. And this is 2 by 3. So that 1 by 3 plus 2 by 3 is equal to 1. XA plus XB is equal to 1. XA 2 by 3 and XB, that is equal to 1 by 3. That is the mole fraction of each component. You got it? Sometimes instead of number of moles, you will be given only the mass. You will be given the mass. Say for example, 18 gram of glucose dissolves. 18 gram of glucose dissolves in say 80 gram of water, like that. The masses will be given instead of the number of moles. Then you have to calculate the number of moles. How do you get the number of moles? So number of moles that is equal to mass in gram, mass of the substance. Mass in gram by molar mass, molecular mass, and that will be the number of moles. If the mass is given, then you have to convert that mass into number of moles. And to get number of moles, you have to take the ratio between the mass in gram and the molar mass. That will give you the number of moles. Okay. All these things are needed for the next year. There is a very long chapter, solutions. In that chapter, we will be dealing with all these things in detail. At that time, all these points are required. Let us think of another term by which the concentration of a solution is expressed, and it is the molality. Molality, and it is expressed in small m. Molality. What's meant by molality of a solution? That is number of moles of solute. Number of moles of solute in 1 kilogram of the solvent per kilogram of a solvent. Here there is a twist. Here we take 1 kilogram of the solvent. Number of moles of solute per kilogram of the solvent. Not the volume, not the number of moles, but in 1 kilogram of the solvent. So there is a relation to get the molality small m. Molality small m is equal to, how can you calculate that? Number of moles of the solute per kilogram of the solvent. So number of moles of solute by mass of solvent. Mass of a solvent. Here it is solvent. Mass of solvent in kilogram. That is the equation used. Say number of moles of solute by mass of the solvent in kilogram, and that will give you the molality of the solution. And what will be the unit of molality? In the numerator, there is number of moles. The numerator, there is a number of moles. So, mole in the numerator, you take the dimensional formula by mass of solvent in kilogram. So, kilogram unit is in the denominator. So, it is per kilogram or kilogram raised to minus 1. Kilogram inverse 1. Kilogram raised to minus 1. So, mole per kilogram, that is the unit of molality. Let us solve a problem. You write a problem. You write. That is not given in the notes. You write. You write a problem. 1 mole of glucose. 1 mole of glucose dissolves in 2 kilogram of water. 2 kilogram of water. Find out the molality of the solution. Molality of the solution. What is the molality of the solution? You use the Stokes equation. Molality small m is equal to number of moles of glucose 1 by mass of the solvent in kilogram by 2. That is equal to 0.5, and the unit, that is a number of mole per kilogram, and that is the molality of the solution. If number of moles is not directly given, then you convert that into number of moles. And to get number of moles, what you have to do? You divide mass in gram by molar mass. You can write another problem. Write one more problem. Calculate the molality of a solution. Calculate molality of the solution. Solution containing 18 gram of glucose. 18 gram of glucose in 2 kilogram of water. 2 kilogram of water. 2 kilogram of water. 18 gram of glucose in 2 kilogram of water. You have to find out the molality. To find out the molality, we need number of moles of glucose. But number of moles of glucose is not directly given. You are given only the mass. So you find out the number of moles of glucose first. So our Stokes equation is this. Molality is equal to moles of number of moles of solute. Solute is glucose here by mass of solvent. Mass of solvent in kilogram. But here mass of the solvent is given in kilogram, 2 kilogram. But mass of the solute glucose is not given. Mass is given, not number of moles. So you convert that into the number of moles. How to get? So number of moles is equal to mass in gram by molar mass. So moles of number of moles of glucose. Number of moles of glucose. Glucose is C6H12O6. C6H12O6, that is glucose. Number of moles of glucose is equal to mass in gram. Mass is 18 by molar mass of glucose. Molar mass is not given. You have to find out the molar mass. How to get the molar mass? You would add all the atomic masses. C6, H12, O6. You add all these things. Then you will get the molar mass. So C6, H12, O6, find it out. Carbon, atomic mass 12 into 6. Then hydrogen, atomic mass 1 into 12. Then oxygen, atomic mass 16 into 6. You add all this, then you will get 180. That is the molecular mass of glucose, C6H12O6. That is equal to 180. So 18 by 180, 18 by 180. And this is equal to, you simplify that, 1 by 10, 1 by 10, that is equal to 0.1. 0.1, that is a number of moles. Now you can find out molality M, small m. Therefore, M is equal to, molality is equal to number of moles of solute glucose 0.1 by mass of the solvent in kilogram, that is equal to 2. And this is so much, you simplify it yourself. You simplify. I shall give the unit. So this is equal to, you simplify, the unit is so much mole per kilogram. Mole per kilogram. You simplify. Take it as a homework. Okay. There is one more term to express the concentration of a solution, and it is molarity. Molarity, capital M, molarity of a solution. And what is meant by molarity? That is number of moles of a solute, number of moles of solute per liter of solution. Per liter of a solution. Per liter of solution, that is called the molarity, capital M, molarity of the solution. Number of moles of solute per liter of the solution. Volume of the solution is to be considered. Not only that, that volume must be expressed in liter also. The unit should be liter. So we can write M is equal to number of moles of solute, number of moles of solute by volume of solution. Volume of solution in liter. The unit is liter. In liter. Volume of the solution in liter, and that is the unit, the equation for molarity. And what will be the unit? Say number of moles of solute in the numerator. So mole and volume in liter, that is in the denominator. So mole per liter, and that is the unit of molarity. Unit of molarity, mole per liter. See, in this case, there is the unit, the volume unit is there. Volume is involved. Since volume of the solution is involved in this calculation, volume of the solution is involved in this calculation, molarity depends on temperature, because volume of the solution varies with the temperature. Volume of the solution, volume changes with the temperature. And so molarity depends on temperature. All the other terms, mass percentage, mole fraction, molarity, all these terms are independent of temperature, while molarity is dependent on temperature. It depends on temperature. It varies with the temperature, molarity. If you are not directly given the number of moles of the solute, then what you have to do? You have to convert the mass into number of moles as before. Let us do a problem based on that. You please take down the problem. Calculate the molarity of the solution. Molarity of the solution of 18 gram glucose, 18 gram glucose, C6 H12O6. C6 H12O6. In say 800 ml of water. 800 ml of water. 800 ml of water. Find out the molarity. You write M is equal to number of moles of solute. Solute here is glucose. Number of moles of glucose by volume of solution. Volume of solution in liter. In liter. Number of moles of glucose, that is not given. So you have to find out the number of moles of glucose. Number of moles of glucose is equal to mass in gram, that is 18, by molar mass. We have calculated molar mass in the last problem, 180, and that is equal to 0.1. Number of moles of glucose is equal to 0.1. Volume of solution. Here volume is given in ml. So volume of solution, you take the volume of water as the volume of the solution. That is equal to 800 ml. You convert that into liter. 1000 ml, the conversion factor, that is already given. 1000 ml is equal to, milliliter is equal to 1 liter. So you divide this by 1000, and this is equal to 0.8 liter. 0.8 liter. Number of moles of glucose, 0.1. You substitute these values in the former equation. Therefore, M is equal to number of moles of glucose, 0.1, by volume of solution in liter, that is equal to 0.8. You simplify that, and the unit will be, you simplify. Unit is so much mole per liter. You must write the unit also. Then only you will be given the full credit. You simplify it at your home. It is given as a homework. So these are the various terms used to express the concentrations of solutions. What are the terms? The mass percentage, then mole fraction, molality, and molarity. Out of this, molarity depends on temperature, because there is volume term involved in the denominator, and it varies with the temperature. Volume changes with the temperature. So molarity also depends on temperature. All the other terms, they are independent of temperature. And it finishes the chapter basic concepts of chemistry. This much is enough for us. And this must be compulsorily studied for the second year. This is all these topics are very necessary for the secondary year. You should not avoid these things. Study this well. Okay, let me stop now. It is time. Thank you. Meet again.